Welcome to today's class. I'm glad you are there with me. I want us to look at refraction of light through triangular prism. If you have not watched our videos on refraction, the laws of refraction and the definition, please check the link in the description down below. Now, let us look at what we have for the day. Now, this by triangular prism is just like this face. Now, if you have this face where light, we can incident light at this face, then that light will always come out from this face. Or, of course, looking at it this way is equilateral. From here, we have this side, we have this side, and we have this side as well. So I want us to look at when we have light incident at this side, and that light will pass from this face. So let us represent it. Now we have, if we have our ruler, we can draw this. And here. We label here A, B, C. Now these are the three faces. This face, the BA, AC, and the BC. Now, assuming we pick this side, we can make a point here. Incident light. If light is incident from the face, we'll have here as our incident. Remember, we can always use dotted lines to extend this. Now, this is the interface between this prism and air. Here is air, here is prism. Now, here is incident ray. If we draw a normal line here, this is a normal line. Of course, normal line is always 90 degrees. We can label here N. Let's say N1 here. We can have here as 0, or as O, N-O. So, of course, this incident ray here, if you look at it from this side, from the BC, we can see this. If you look at it from AC, we can see CE. But for the benefit of this lesson, we're going to concentrate only on the face AC. Now, assuming we have this face AC here, this ray will emerge. It will emerge from here. This is our emergent ray. Remember, this side is off. So from here, from this face, we can now draw another normal line here. We can draw another normal line here. Remember, 90 degrees. So we can have here N2 here, and we have 0. If here is 1, we can have here 2 here. Now, from here, this is emergent ray. Between the normal and this emergent ray, we can have, sorry, this is the N2, please, not N squared. We can have our emergent, angle of emergence. Now, between this normal here and the incident ray, we have our angle of incidence. Now, we can join here and here. If we join these 2 points, we have that here is our angle of refraction. Of course, is equal to this one. So we have this R here, we have this R here. This angle here is equal to this angle here. Remember, this one, I want you to note this. This A here is the refraction angle of the prism. Very important. Refraction angle of the prism. Now, there are basically 2 types of prisms. Once we have equilateral, equilateral means the 3 sides are equal. And of course, the angle that form this equilateral triangle is 60 degrees. 60 plus 60 plus 60 will give us 180 degrees. So the interior angle of an equilateral triangle is 180 degrees. Therefore, here, this refracting angle A is equal to 60 degrees. Or even if it is not given, provided from the question, they say equilateral triangle is always 60 degrees. So, or they can use 45 degrees. A can also be 45. So, there are two different triangles, prisms, please. There are 45 degree prism and there are 60 degree prism. But basically, we use 60 degrees prism. Unless from the question, if they say A is 45, please use A to be 45. Okay. Now we have, I want us to note that I is angle of incidence, E is angle of emergence, R angle of refraction. Now, remember, an angle is formed here. This is the incident ray, this is the emergent ray. This point of intersection between the original direction and the final direction of the ray, an angle is formed here. Here is called the deviation. So this angle here, this angle between the original direction and the final direction, the angle formed here is a deviation. D is the angle of deviation. Okay. Now we have that I want us to know that I, E, and D, they work hand in hand. However, this deviation depends on the value of I. As you increase the angle of incidence, D will reduce. As you are going to increase this angle, D will continue to decrease. Now, a particular angle of incidence where the angle of deviation ceases to decrease is known as the angle of minimum deviation. Angle of minimum deviation. Angle of minimum deviation. We can have it as D mean. Most books will have it as capital G or GM. However you want to take it, please. Either you have it as D, or you can write it as D mean. So we have discussed D, which is the deviation. So we say that particular angle of incidence at which D, the deviation, ceases to decrease is known as angle of minimum deviation. So we have here D subscript M is angle of minimum deviation. Now, at D minimum, at angle of minimum deviation, this ray, this refracted ray will be parallel with the base of the prism, become parallel with the base of the prism. And then if it becomes parallel with the base of the prism, so we now say that at minimum deviation, at D mean, I is equal to the angle of emergence. So these two become the same. So we now have, if this is our triangular prism A, B, C. Now at minimum deviation, this is what we have. At minimum deviation, this is what we have as our, so here is I, here is E. Now this ray passes symmetrically, the refracted ray passes symmetrically with the base of the prism. So we now have, so the first thing we have here, at D mean, I is equal to, I becomes equal to the angle of emergence. The second one, at D mean, A is equal to 2R. The refraction angle of the prism becomes R plus R is equal to 2R. So I want us to note that one too. So okay, so we say at D minimum, we have that D is equal to 2I minus 2R. Remember, here, 2R is equal to A. I'm going to replace it here. Now, remember, before this one, we have that D is equal to 2I minus the refracting angle of the prism. So, note this formula, note this formula. Now, at minimum deviation, angle of refraction now, R is equal to A all over 2. So, these are the vital points I want us to note. So, this is the minimum deviation. At minimum deviation, we have that 2I minus A. When I have at minimum deviation also, the angle of refraction is equal to the refracting angle A all over 2. And also, we now have, if A is known, D mean is known, then we can calculate our refractive index. So, if we want to calculate our refractive index, we can now have our formula as refractive index is equal to sine half into, we have A, which is the refraction angle of the prism, plus D mean all over sine A over 2. So this is our formula for calculating the refractive index. Okay, let us take one or two calculations using this formula. Okay, the first question says, a ray of light is incident on an equilateral triangular prism of refractive index 3 over 4. Of refractive index 3 over 4. Calculate the angle through which the ray is minimally deviated in the prism. Calculate the angle through which the ray is minimally deviated in the prism. So we now have, from here, solution. Refractive index is equal to 4 over 3. 4 over 3. And we have also that, please, the refractive index is 3 over 2, please. 3 over 2. Now, refraction angle of the prism, 60 degrees. Now, D mean is what we are looking for. So, we now have, we substitute into this. If we substitute into this, we have 3 over 2 is equal to sine half into A 60 plus D all over sine 60 all over 2, which will give us 3 over 2 is equal to sine half into 60 plus D mean over sine, of course, 60 over this will give us 30. So we have sine 30. We continue. 3 over 2 is equal to sine half into 60 plus D mean all over sine 30 is 0.5, which will now give us, and of course, 3 over 2 is 1.5. 1.5 is equal to sine half into 60 plus D mean over 0.5. At this point, we are going to cross multiply. So if we cross multiply, 1.5 times 0.5 will give us 0.75. So 0.75 is equal to sine half into 60 plus D mean. Okay. At this point, we are going to divide both sides because of this half here. we are going to divide both side by sine. So if we divide both side by sine, we have 0.75 all over sine is equal to sine half over sine into 60 plus d mean. Now at this point, sine can take care of sine. And if sine takes care of sine, we have 0.75 all over sine is equal to, now we can now expand. Half times 60 will give us 60 over 2 plus d mean all over 2. At this point, we can take the sine inverse of this, yes. If we take the sine inverse of this, we will now have sine inverse of 0.075 is equal to, now this over this will give us 30 plus d mean all over 2. So remember, we just, this over this means sine inverse, that is why we have to take the sine inverse. So sine inverse of this is equal to 60 over 2, which is 30 plus d mean over 2. Now at this point, so we can sine inverse of 0.75 by calculation will give us 48.59 equal to 30 plus d mean over 2. Now we can connect like terms. Send this one here. If we send it here, we now have 48.59 is equal to minus 30 is equal to d mean over 2. Now, if we subtract, we'll now have 18.59 is equal to d mean all over 2. So, if we cross multiply here to make d mean the subject, so d mean will now give us 18.959 times 2. So, the angle of minimum deviation will now give us 18 times that value will give us 37.2 degrees. So this is the angle through which the ray is minimally deviated. All right, this is where we are going to end the lesson. Please, for other calculations, join me in our next video. Thank you very much for being here with me. Please do not forget to hit the like button, subscribe to this channel so that you will get notified when I drop other videos, because there are other calculations that I'm going to drop. Please, until we meet there. Thank you.